Hi students, I am Praveen Sebastian Paul. In this lecture we are discussing another SDLC model. It is V model. The V model is an SDLC model where execution of the process happens in a sequential manner in a V shape. It is also known as verification and validation model. The V model is an extension of the waterfall model and it is based on the association of a testing phase for each corresponding development stage. This means that for every single phase in the development cycle, there is a directly associated testing phase. This is highly disciplined model and the next phase starts only after completion of the previous stage. Under the V model, the corresponding testing phases of the development phase is planned in a parallel manner. So there is a verification phase on one side of the V and validation phase on another side of the V. The coding phase joins two stages of the V model. So as we discussed in the V model, the one side of the V is the verification phase and another side of the V is the validation phase, and both these sides are combined or joined by the coding phase. So when we come to the verification phase, different phases are requirement analysis, system design, architecture design and module design. Validation phase, those phases are acceptance testing, which is connected to the requirement analysis. Next is system testing, which is connected to the system design. Another one is integration testing, which is connected to the architecture design. And another one is unit testing, which is connected to the module design. So these verifications and validations are connected by the coding section. So when we come to the verification phase, there are four different phases. Those phases are business requirement analysis, system design, architecture design and module design. So the business requirement analysis is the first phase in the development life cycle where the product requirements are understood from the customer's perspective. This phase involves detailed communication with the customer to understand his explanations and exact requirements. This is a very important activity and need to be managed well, as most of the customers are not sure about what exactly they need. The acceptance test phase planning is done at this stage, as business requirement can be used as an input for acceptance testing. The second phase is system design. Once you have clear and detailed product requirement, it is time to design the complete system. The system design will have the understanding and detailing the complete hardware and communication setup for the product under development. The system test plan is developed based on the system design. Doing this at an early stage leaves more time for the actual test execution later. The third phase is architectural design. The architectural specifications are understood and designed in this phase. Usually, more than one technical approach is proposed, and based on the technical and financial feasibility, the final decision is taken. The system design is broken down further into modules taking up different functionality. This is also referred to as high-level design, HLD. The data transfer and communication between internal modules and with the other outside world is clearly understood and defined in this stage. With this information, the integration test can be designed and documented during the phase. And the fourth verification module is module design. In this phase, the detailed internal design for all the system modules is specified, referred to as low-level design. It is important that the design is compatible with other modules in the system architecture and other external systems. The unit tests are an essential part of any development process and help eliminate the maximum fault and errors at a very early stage. These unit tests can be designed at this stage based on the internal module designs. So these are the four different levels of verification phases. The phases are business requirement analysis, system design, architectural design, and module design. And after all these phases, we are coming to the coding phase. The actual coding of the system modules designed in the design phase is taken up in the coding phase. The best suitable programming language is decided based on the system and architectural requirements. The coding is performed based on the coding guidelines and standards. The code goes through numerous code reviews and is optimized for best performance before the final building process is implemented and is checked into its repositories. So the coding phase is the actual implementation of the programming or the project under consideration. After the coding phase is completed, we are moving to the validation phase, and this phase consists of 4 different procedures. They are unit testing, integration testing, system testing, and acceptance testing. The unit tests designed in the module design phase are executed on the code during this validation phase. Unit testing is the testing at code level and helps to eliminate bugs at the early stages through all defects, though it should also be considered that all the defects cannot be uncovered by the unit testing phase. And the next phase is integration testing. The integration testing is associated with the architectural designing phase. The integration testing are performed to test the coexistence and communication of the internal modules within the system. And the third phase is system testing phase. The system testing is directly associated with the system design phase. System testing checks the entire system's functionality and the communication of the system under development with external systems. Most of the software and hardware compatibility issues can be uncovered during the system test execution. And the final one is acceptance testing. The acceptance testing is associated with the business requirement analysis phase and involves testing the product in user environment. Acceptance testing uncover the compatibility issues with the other systems available in the user environment. It also discovers the non-functional issues such as load and performance defects in the actual user environment. So these are the different phases of validation step. Those steps are unit testing, integration testing, system testing, and acceptance testing. When we come to the advantage and disadvantage of this V-shaped model, the advantages are: it is not easy to use since the testing activities like planning and test designing are done before the coding. It is easy to use since the testing activities like planning and test designing are done before the coding phase. This model enhances the chances of success and save the time, and the defects are mostly found at the early stages and downward flow of the defects is generally avoided. So these are the major advantages. And when we come to the disadvantages, the V model is a rigid model, as well as the software is developed during the implementation phase, so the early prototypes of the products are not available. And if there are changes in the midway, you need to update the test documents in this phase. So these are the disadvantages of V-shaped SDLC model. So my dear students, hope you had understood this topic. Dear students, kindly go through this assignment questions. The questions are: write in detail about V model. And the second question is: compare the advantage and disadvantages of V model. So dear students, in the upcoming lecture we will discuss the agile model of SDLC. So see you soon. Until then, goodbye. Thank you and all the best.